Yeah, let's start off everyone. Then this was the last thing that we did. Let's go ahead with the problem. So we have a shape like this. This radius is A. This thickness is D. This height is L. This angle is theta. And this A is much, much greater than D, so that we can neglect the fringe effect. So at the edges, right, the current won't be uniform. So we want to ignore that. Rho is the resistivity and N is the number of electrons per unit volume. So if you look at the same picture from the top view, this is how it looks. The battery terminals are these things. So battery is connected between these 2 points. Is everyone getting the picture how it is? So that slice, it's like an arc which has a thickness and a width. So first question, find R equivalent, find current. Second thing, find V drift as function of x, where x is the distance from center. Meaning, if you take a distance x from here, what is the velocity of the electrons? Drift velocity as function of x. Then something also happens here. If you look at the inner circumference and the outer circumference, if you take them as C and D, you actually get a potential difference. Find VC minus VD. This is called transverse voltage. We will talk about that, see why you get it. But let's get the first two parts. This is the potential difference across inner and the outer circumference. C is a good one. Let's get the resistance. And the first thing is, how do you choose your element? Try. I'll give you a minute more for R equivalent. Taking an element like this is a bad idea. Why? The length itself is getting messed up, isn't it? So this is what we do. At a distance x from center, take a thin slice like this, whose thickness is dx. You're getting how is the slice? And this length will be x into theta. Now remember, here the current is flowing along this arc, and the current is coming out of this cross section. This length was L. So when you write the resistance of this thin strip, dr, it will be rho. Length will be the length along the current flow, which is x theta, by area perpendicular to the current flow, which is L dx. Is that clear, everyone? Now here, one common mistake what people do, they try to integrate this. This is a blunder. Understand the meaning of integration. It is a summation. So here, tell me one thing. All these strips are in what? Series or parallel? All the strips are in parallel. They have same potential difference, isn't it? If you remember the last question we did, this pair here all were in series because same current flows through them. Here all the strips are in parallel. They don't have the same current. So when they're in parallel, and how do you even integrate dx in the denominator? All strips are in parallel. So if they're in parallel, that means 1 by R equivalent. The formula is 1 by R1 plus 1 by R2, so on by 1 by R power n. So that means if you want to find 1 by R equivalent, you need to do summation of 1 by dr, isn't it? So you don't integrate dr, you integrate 1 by dr, and that will give you 1 by R equivalent. Is that making sense? That is the meaning of integration. You just don't do integral dr doesn't become R. Integration means summation of small pieces. So here you have to do the reverse summation. So this guy will be how much? L by rho theta integral dx by x. Limits will go from a to a plus d. So this will give me R equivalent is equal to rho theta by L ln a plus d by a. I think I wrote reverse. Yeah, reverse. Ln a plus d by a. This is your R equivalent, and current is how much? V by R equivalent. There I got the current. Now, how do you find the drift velocity? This is the first question, R equivalent. This itself is a pretty good mains level question. Even at an advanced level, I can say this will be a part of maybe a more than one choice. Now the question is find the drift velocity as function of x. So each strip, electrons will go with different speeds. Let's get that. Find the drift velocity as function of x. There's only one formula for drift velocity. I is equal to NEA V drift. Isn't it? What is I? Current in the strip. What is A? Area of the strip. What is V drift? Drift velocity of electrons in that strip. Try, you got a minute. N is given, number of electrons per volume is N. That itself could be a good integer question. V drift is proportional to 1 by x power n. Find n. So in this strip, we have a current Di. Di is the potential difference V by dr. So every strip will carry different amounts of current. So this will be V by rho x theta L dx. This is Di. And we know current is nothing but NEA V drift. And area is nothing but L dx. L dx cancels off. So we get V drift is voltage by rho theta NE 1 by x. It's proportional to 1 by x. That means the electrons closer to the this thing will go faster, and the electrons on the outer edge are actually going slower, isn't it? The farther the thing, the slower the electrons going. So all the electrons won't be reaching at the same time. Is this clear, everyone? And this comes to the third part. Now something happens. This thing is not a straight line, it is a circular path. If particles go in a circular path, what do you think will happen? There will be a centrifugal force which will start dragging you. So this leads to something. Any doubt so far till here, everyone? Vihan, clear with this? Arnav, Saish, Aditya, clear? So if you look at this, these electrons are going on a curve. Now, when the electrons start going, with a drift velocity v drift, this will result in a centrifugal force. This will be the mass of the electron, mv drift square by x. That means the electrons will start getting pushed onto the outermost surface. And because of this outermost surface starts becoming negative charged. And the inside starts becoming positively charged. So these induced charges will create a field which is radial direction. Now this field is electrostatics in nature. So this E bar is an electric field due to the induced charges. Now initially what will happen? Some electrons will go there, so there'll be some charge. So this electric field will try to drag the electrons back here, isn't it? The electrons will experience a force opposite to the field. Is that making sense? As more and more electrons accumulate on the outer surface, when an electron tries to go, it gets repelled. Eventually, you reach a steady state. So in steady state, now see, electrons are still going forward. So these electrons will stop drifting. In steady state, the centrifugal force and the electric force will balance out. So this will be mv drift square by x. This will be m by ex. And what is v drift? V drift we calculated here, which is v square, rho square, theta square, n square, e square, 1 by x square. So if you see, the field is actually proportional to 1 by x cube. This is another question they can ask you. The electric field in the radial direction is how much? There are actually two electric fields in this conductor. One electric field is this direction, remember, that is J is equal to sigma E. That's a different electric field. This is a different electric field. There are two electric fields which are present in the region. And this electric field will get cancelled out because of the induced charges. This is the one who is actually balancing the centrifugal force. So if I write this electric field is equal to some constant k by x cube. K is a constant. If you see all that thing is a constant, this is your radial electric field. And then we know, if you know electric field, then I can use the potential difference. Vc minus Vd will be minus integral E dot dr. Limits will be from a to a plus d, c is inside. Then you can just integrate this. This will be k by x cube dx will be k by x square. 3k by x square. X power minus 3, so that is x power minus 3 by minus 3 plus 1, so that is 1 by 2. Integral 1 by x square will be 1 by a square by 1 by a plus d whole square into k. This is your transverse voltage. This will be the potential difference between the inner surface and the outer surface. Luckily, you have taken A is much greater than D. So kind of what happens in real life, if A is much greater than D, this becomes almost negligible. But then again, I can use binomial approximation. I can solve this also. They can ask you that also. Find the transverse voltage as function of thickness. Are you clear why you're getting a transverse voltage? This is all happening because you're letting the current go in a circle. If this had been a straight conductor, you won't have this problem. Because the electrons are going in an arc, the centrifugal force is pushing them out, and they started accumulating on the surfaces, creating a counter field. And this field is balancing the centrifugal force. So eventually, the electrons will stop drifting outside. You reached a steady state. They're just going along the arc. Is this clear, everyone? This would have been an advanced paragraph. There, you have your current, circular motion, electric field, potential. Any doubts on this? It's a good one. Should definitely check it out. Especially the things that I like is, this E proportional to 1 by x cube, V drift is proportional to 1 by x. They can ask a lot of simple, small questions in this. It could be even make it into a matrix matching. Worthy question. Next one. Everyone got the steps? Let's get this. Find RAD. Find the resistance between AD and find the resistance between RBC. So A and D are these 2 points. These are A and D. These are B and C. 2 different questions. If you put the battery between A and D, find the resistance. If you put the battery between C and C, find the resistance. Values are given 1, 1, 2, and all are not equal. Get this. You got 1.5 minutes for each. Did you guys realize the symmetry? AD is what symmetry? Axial symmetry. The line of symmetry is passing through the terminals. That is called axial symmetry. Just because it is vertical, don't call it bisector. Bisector के लिए the terminals will be on either side of the symmetrical line. Try. Get this. Get me an answer. Hi, your chat box is fine. Your juniors का when I open the chat box, I get something really weird. ठीक है. First one, AD, any answers? BC you did. नहीं रे, BC का आंसर वो नहीं है. Any answers for AD? Try. 2 more minutes. So first I'll show you AD, then I'll show you BC, so you'll have time for the second one. Try. Right, Niharika. You got the first one right. Get the second one. We are doing AD. If you see, if I draw the line here, with this is an axial symmetry. I can fold the circuit, but it also means the left and right are identical. If the left and right are identical, that means if you look at this E ka potential and F ka potential is same. Agreed? Similarly, B ka potential and C ka potential is same. Agreed? Left and right have identical potentials. So if they have same potentials, that means I can remove the resistor between them. E and F have same potential. B and C have same potential. That means I can remove this guy in the middle. I can remove this EF. I can remove this BC also. If you want to fold it, you can fold it also. But you know, when you fold, what happens? It looks like this. When you fold it, that resistor will be like this and comes back to the same point, isn't it? So that is as good as it is. You can remove it, isn't it? It just comes and joins back to the same point there. Nere Vihan, that is wrong. Niharika, you got reverse. So you can remove the resistors in the middle. Be careful, don't use capacitor formulas here. Then you're done. Now look at this thing. This one, this two, and this one, all three are in series. Those three are in series. Same current flows there. That becomes 4 ohms. So your circuit will look like this. So the central resistor will be 2. The left resistor will be 4. The right resistor will be 4. RAD is 1 ohm. Check.
Sir,
Yeah.
sir, if we fold it, like we would get, like, for example, the resistance between D and F would become 2 ohms and AC would become
D and F.
4 ohms.
Arre God, they're in parallel. Resistors in parallel will become what? Half. They won't double. Capacitors in parallel will add up. Resistors in parallel will become half. When you fold them, what will happen? They'll all will become half.
Okay, got it, sir.
Don't remember like that. When you fold them, they're in parallel. If it is capacitors, it will be C1 plus C2. If it is resistors, it is R1 R2 by R1 plus R2. You double them.
Got it, sir.
All clear with this? Question अभी तक हुआ नहीं. BC. What is the answer for BC? Niharika, we have an answer. Others? Anyone else got for B and C? Nay, Anshu, that is wrong. How did you even get that? It's a weird number. It's not really that weird, but ठीक है, it's not. B and C, everyone. AD all clear? So when you do for B and C, this is your line of symmetry. This is your bisector. So what happens on a bisector symmetry? It is equipotential. That means any resistor between these terminals can be removed. That means you can remove A and D. This resistor is gone because A and D have same potential. So the resistor between A and D can be removed. Then you're done. These two are in series, parallel, let's solve them. So if you do this, you'll get RBC is equal to 7 by 12. Check that out. I remember the answer. Niharika also got it. Anyone else got it? Nope, no one else got it other than Niharika. I'll give you 30 seconds to solve and check it out. Yeah, Aditya, that is also wrong. But did all agree that I can remove that AD? I think you guys are getting confused between capacitors and resistors formula. Yeah. Be careful there. I think you guys are goofing up. That's what is happening. Series parallel, thoda dhyan rakho. This entire middle branch will get solved off. That will be how much? 2 by 3. This entire in the center is 2 by 3. 2 plus 2, they will add up all three of them. This one are in series. That and this will be in parallel. This will be in parallel. The whole thing becomes series parallel once you remove that AD. Yeah, Rose also got it. Anyone else? One more. Devant also got it. Chalo, everyone got it. Going ahead. All clear with this? Figure it out. That is all series parallel. Should be able to get it. Next thing. Kirchhoff's junction law. Again, same stuff. What we did there in capacitors. There it was charge. Here it is current. So this thing says the net current entering a node is 0. So if you have I1, I2, and I3, I1 plus I2 plus I3 will be 0. So how do we use this? If you have resistance R1, R2, R3, same example, there I used capacitors. Here I'm using resistors. Let the voltage be V1, V3, and V2. Let this be X. Let the current be I1, let the current be I2, let the current be I3. We know the total current entering the node is 0, so I1 plus I2, 3 is equal to 0. What is the current ka formula? Potential difference by resistance. Current always flows from higher to lower potential. So you're saying current is going from V1 to X, meaning V1 is higher than X. So V1 minus X by R1, I2 is V2 minus X by R2, and V3 minus X by R3 is equal to 0. Get X from here, substitute, you'll get the currents. In case of capacitance, remember what we did? We used to write charges. So we used to capacitance into voltage difference. Here it is voltage difference by resistance. All clear with that? So how do we use this? If you go back to the capacitors, how did we solve these kind of circuits? Step 1, choose a point with zero potential. Step 2, find the potential of other nodes and name the unknown nodes. Step 3, apply junction law. These were the steps we used in capacitors. We use the same thing, except instead of charge, we call it current. So let's see a small question and then we will go ahead with more. Exact same thing. I just replaced capacitors with this. So this is 2R, R, R, R. Find current in each branch. There's nothing in series, nothing in parallel, no nodal analysis, no symmetry, nothing is there. So like I said, we have 5 techniques: series, parallel, Wheatstone, nodal analysis, symmetries. And the 5th one is Kirchhoff's law. You can't use the first 4, go ahead with Kirchhoff's junction law and the loop law. So we will see both. Try, Pushkal, give it a try. And do make sure to revise your notes on regular basis. When you don't revise, that's what happens. You keep staring like, what is happening here? Step 1, assume any point is 0. I'll take this as 0, 0, 0. Then this will be 2V. This will be V. The center, I don't know, X. इतना तो आया होगा सबको. Then we say this is I1, this is I2, this is I3. You got to take in different symbols. Try, finish it off. Then if you have done here, then apply the junction law there, get X ka value. I'll give you a minute more to solve. This is the process. This is how you get the steps.
Sir, how did you get 0 in between?
What do you think it should be?
Can we assume?
If it is, why will you assume? Let me ask you, what is this? What is that? Tell now, whatever you think, you tell. What is that? This part, what is this part? Whatever you think, Re Puroja, bolo na, what is that part? Confused? No, I'm just asking, what is that thing called? Suppose if I put a resistor, if I put a like this and resistor, what is this thing?
Wire.
A wire, right? And a wire is? What is the potential of a wire? क्या हो गया? You blanked out. What does a wire do? If you connect two things with a wire, what does a wire do?
Make the potential
Same. So, yeah, बस वही था और कुछ नहीं. So this entire wire will have
same
potential. So if that is 0, that has to be 0. Got it? हाँ. बस वही था. You should just say it is wire. बस हो गया. आदित्य गॉड बैटरी यहाँ पे 2 वोल्ट है, तुझे 4 वोल्ट आया वहीं पे. Where did you generate this extra power from? At least, see, it's okay if you get a wrong answer, right? But when you get a blunder, na, you should realize, right? यहाँ पे 2 वोल्ट का बैटरी, 1 वोल्ट का बैटरी, x 4 वोल्ट कहाँ से लेके आओगे बताओ? I think most people got the answer. X का, yeah, 4v by 5, v by 10 are near, and those answers are wrong. Ishan, I think your answers are right. ये देवांश देख बीच में चैटिंग कर रहा है ये. Let's see. So if you write for x का node here, I1 plus I2 plus I3 is 0. This is V minus x by R. I2 is current is going from 0 to x. So see, here I assumed current is going from 0 to x. So 0 is higher. So you don't worry about that. The signs will take care of themselves. I3 is coming from 2V. So 2V minus x by 2R is equal to 0. Solve this, you will get x is equal to 4V by 5. Got this? Once you get this, you will get each current. I1 will be how much? V by 5R. I2 will be minus 4V by 5R, yeah, as expected. I3 will be 3V by 5R. Check. Got the answers? Remember this thing? Same thing we did in capacitors. There we just found charges. Here we're finding currents. Any doubts on this? Anyone not convinced with the process? Any other doubts? Next one. I hope you remember this one. R, 2R, 3R, R, R, and V. Find the current in each branch and R equivalent. Unbalanced Wheatstone bridge. Remember, again the same thing. You start any point as 0 and try to find the rest and get the variables. Try. You'll get 3-4 minutes. Numbers are bad. Exact same question we did in capacitors. It was C, 2C, 3C, and C. Let's see the terminals. Step 1, start with a 0. Always prefer the battery ka negative terminal as 0. So this will automatically become V. This be X, this be Y. Because this is not V, this is not 0. Should be something else. This is not V, this is not 0, this is not X. So it should be something else. So that is Y. You're getting how I'm putting the variables? You're done then. I think then, yeah, this guy will be I1, I2, I3, I4, I5, I6, and this is I1 and this is I4. So through the battery, current is I1 plus I4. So if you write at junction X, I1 plus I2 plus I3 is 0. So this guy will be V minus X by R, plus I2 will be 0 minus X by 2R, plus Y minus X by R is equal to 0. That's one equation. When you do for Y, V minus Y by 3R plus X minus Y by R. Anyone didn't get any particular step? Please ask. Don't hesitate. Get it cleared. Is 0. If you solve them, you'll get X and Y from here. I will leave it to you. Anyone got the value of X and Y by any chance? 29 by 13. I think we got something like this. I don't remember. And how do you find R equivalent? R equivalent is nothing but voltage by current through the battery, which is in this case I1 plus I4. So calculate I1, I4, substitute, you're done. 16 by 29. Okay, X is 16 by 29.
So 16 by 20.
And Y is 11V by 29. It seems. Okay, check it out. Resistance किसी को आया क्या by any chance? We have one answer. Puroja got 29 by 31. Anyone else got that?
Sir.
Ishana, you got 29 by 11. Is that the resistance or the voltage, right, Shana? Resistance. Okay. The answers are not matching. Someone is wrong. Anyone else? One more answer to confirm. We have 29 by 31 and we have 29 by 11. 29 by 31. We have 21. Okay, we have 29 by 31. We have 4 answers. So do check. Could be right. But clear the steps. I think once you got the equation, job is done, isn't it? It's lengthy in terms of numbers, but that is how you do this thing. Any doubts on this? Arush, Aditya, Vivan, clear? Pushkal, got it? Ahana? Ishana, check kar lo where you went wrong. Maybe some calculation mistake hoga. Next one. This is still a good one, but theek hai, matlab, next one is a really good one. There, we have a big branch of circuits here. All resistances, let's take it as 1 ohm. Look at this thing, the central branch here, 1 ampere is flowing, 1 ampere is going in, 1 ampere is going out, 1 ampere is going in, 1 ampere, 1 ampere, 1 ampere. So if you see the total current entering the node is 0. 4 currents are entering and 4 are leaving. So the question is, using this data and all resistance are 1 ohm, can you find the current in the branch AB? Think how will you do this thing? Like I said, what we did in capacitors, we'll not repeat most of the problems. We'll try to do something different. Except for a few common models. How do we approach this? I think I'll give you 3-4 minutes. 3 minutes I'll give you. Think for a minute or so. I'll give you a hint and then I'll give you more time. Frankly, I would have loved to give you this as a homework, but okay, let's try. Start from here. Let the center be 0. Okay. Then find the potential of this point, this point, this point, and this point. Can you find these 4 points ka potential? Start from there. Take the center as 0 and you have 4 green things which are marked. Find that potential. That should give you some info. Center is 0. Current in each branch is 1 ampere, and make sure to look at the directions. They're going in and out. And all resistance are 1 ohms. But when you see this question, right, what do you think the answer will be? If you have to guess an answer, how do you think it will look like? When I saw this question for the first time, I thought the answer will be either 1 or 2 or 4 or 8 or 16. I thought something like that. Let's see what we'll get. Get the potential of those 4 spots. Potential can't be -1 ohm रे. क्या हो गया boss आज तुझे? Didn't have dinner. I can understand when you don't eat food, things happen like that. So it's okay. In case you're wondering, I'll name it for them. Okay, this is called A, B, C, D. Chalo, abhi nikalo. Potential of A, B, C, D. They're not same. This you could have figured out, right? देखो ना, this is 0. This 1 ampere is flowing. The potential difference across the resistor is 1 volt. So current flows from higher to lower voltage. So B must be +1, na? And C should be -1, right? A should be +1, isn't it? Look at the current direction. Current always flows from higher to lower potential. And this current is 1 ampere and resistor is 1 ohm. So potential difference is 1 volt. Yes or no? Resistance is 1 ohm. Current is 1 ampere. Potential difference is 1 volt. Yahan is surprised. What are you surprised about? Bolo.
So won't A be -1 then?
So current flows from -1 to 0. Which is bigger, -1 or 0? Current flows from higher to lower potential. Current is going to 0. Should it be +1 or -1? Hey God, itna confusion hai re. Current goes here. This is plus, this is minus. This should be higher voltage. This is 1 and this is 0.
Awesome. Yes, sir.
Yeah. See how to get this question. So if you got this, anyone got D ka potential? Won't it be -1 at A? Yeah, A is also -1. I'm sorry. That is your confusion. I was talking about B. Okay. My mistake. Sorry. Then what about D? किसी को आया है? Someone typed. Purvaja. Hey, this stupid thing, na Zoom ka. I have to click each of your name to see what you are messaging. 6. Yeah, right home. Listen, what makes this question right? It's pretty simple to solve, but it's a headache to even figure out what the hell was happening. So this point will be +1. This point will be -1, and this point will be +1. Now look at carefully. If this is +1 and -1, what is the potential difference? 2 volt. If that is 2 volt, that means this current will be 2 ampere. Agreed? If this is +1 and this is -1, this current also will be 2 ampere. And already 1 ampere is flowing from here. That means in this branch, the current is 5 ampere.
Sir, that will be
Junction law.
-1, no?
Come again?
Right column wala will be -1, right?
Yeah.
नीचे वाला.
Sorry, -1. I am doing that mistake for some reason. But if this is 5 and this is 1, ये point कितना था? +6. Agreed? If that is +6, this also will be same thing. देखो, this is also 2 ampere. This is 1 ampere. So this current is 5 ampere. This is +6. No, -6. If this is +6 and this is -6, what is the potential difference? 12. That means this branch will have current 12 ampere. This branch will be 12 ampere. This branch will have 29 amperes. 12 plus 12 plus 5. Is that making sense, everyone? So you just find the potential, use the junction law, get the current, find the potential. You just keep doing this. So when I got the answer, I was like, what the hell? 29 was something which is completely unexpected for me. Nah, Vignajit. Clear with this? So actually 29 will be, this also will be 29. This will be 29 will go inside. So all these outer branches will have 29. And all these branches will have 5 amperes. Got this? Good one, na? Easy to solve, but the starting point is a difficult thing. And the first thing what happens now when you see such a big circuit, first thing your circuit blows off. Matlab, you're like, what the hell? That is you are in more of a shock than actually solving a question. Next one. Going ahead. Find RAB. All resistance are R. Just get me the equations. These two are in series, huh? And this will be in parallel. So circuit can be little, simplified a little more. That's it. You can't simplify more than that. After that, you're done. Do you guys remember diagonal symmetry? This is a diagonal symmetry. Hope you remember how do we use diagonal symmetry. Remember this example? You guys don't remember. It is there. It is there in the capacitor notes. Same problem I gave as an example. This is a diagonal symmetry. Whatever happens here, same thing happens here. So you get the same potential difference. So I can simplify this. So this whole branch here will be 2R by 3. This whole branch here will be 2R by 3. So if you redraw the circuit, this will be that red resistor. 2R by 3, 2R by 3, and remaining all are R. This is how it looks. Nothing is a Wheatstone bridge here. So if you connect a battery here, let this point be 0. Let this point be V. If this point is X, now see current in this and this must be same. Because from the front and the back, it is the same circuit. If the current is same, that means the potential difference is same. What is the potential difference? V minus X. So this potential difference also must be V minus X. But that is already 0. So this is V minus X. Is that making sense, everyone? Since the current in this and this is same, the potential difference must be same. Here the potential difference is V minus X, so this is also V minus X. Similarly, if this is Y, then this must be V minus Y. So again, we have only two variables. Sure. Then this current will be I1, this current will be I2, this current will be I3. This current is I4, this current is I5, this current is I6, and this current is I7. So Y branch, there are 4 currents. And then you can write, for X it is I1 plus I2 plus I3 is 0. V minus X by 2R by 3. I2 will be Y minus X by R. V minus Y minus X by R. So if you use diagonal symmetry, this makes your life really easy. For Y, it is I1 plus I2, I4, I5, I6, and I7 is 0. I4 is V minus Y by R. Yeah, solving is a pain. But still much better than, you won't be able to solve the circuit normally. X minus Y by R. V minus Y by R. It's just simply actually only two unknown two equations. V minus X minus Y by R. There. So if you solve this, you'll get X and Y from here. What is R equivalent? The current passing through the battery voltage. And what is the current passing through the battery? I1 plus I4. Check. Simplify this later on. Let me know what you got. But if you got till here, I think the physics job is done. Two equates. So the diagonal symmetry will make your life easy. You only have two variables. Or else you have to take X, Y, Z, W, 4 variables you will get. Yeah, I'd write 4 equations and solve 4 of them. It's a pain. All clear with this? Any doubts on this? Take a small break. Come back by 9:40. 5 minutes. Any doubts so far? Anything you're not clear, please ask. Any doubts? Okay, come back in 5 minutes. Each segment is R. Find RAB. Just get me the equations. Others, keep your cams on. What kind of symmetry is there? Axial. So you can fold the circuit. So if at all they ask you questions in advance, this is how it will be. Matlab, you still have to use symmetry, you still have to use Kirchhoff's law. But at a mains level, right, most of the time, if you just use one symmetry, you'll get the answer. Advanced ऐसा नहीं है, it will be more complex. Diagonal. There is a diagonal symmetry also. But that you will see after simplifying, you will see this thing. More than, there's actually a bisector symmetry also. But you can't open any nodes. कुछ है ही नहीं है ना center में nodes. Did you fold it? Got the new resistances? If I fold this, this is how it looks. Now, remember this guy will become R by 2. What we do exactly here, I did this thing. I called this point C. This is also C. If this is D, this is D. If this is E, this is E. And if this is F, and this is F, isn't it? So when you folded them, these two resistors became parallel. Parallel resistance becomes R by 2. This is also R by 2. Now, be careful. These two guys here, who are there, these things are not folding with anyone else. So these things will still remain R. Got it? So they are not falling on anyone else. So if you simplify, if you look at these two are in series, isn't it? R and R by 2 are in series. So if I redraw the circuit, this is how it looks. So this will be R by 2, R by 2, R by 2. This will be R by 2, R by 2, R by 2. This will be 3R by 2 and this will be 3R by 2. Got this. Unfortunately, this is not an extended Wheatstone bridge. You can't remove the middle resistors because this is 1 is to 1 is to 1. This is 3 is to 1 is to 3. If that ratio is maintained, I could have removed in the middle. So yeah, unfortunately, you can't do that. But still, there is, if you see, there is a bisector symmetry. Left and right is same. That means if you take this point as X, this is V, this is 0. The current in this branch and this branch must be same. Therefore, this point must be V minus X. If this is Y, this point must be V minus Y. So there's still a symmetry. Is that clear, everyone? Current flowing here must be equal to current flowing here. The potential difference must be same. Yes, luckily still there are only two variables. So I1, I2, I3, I4, I5, I6. You know how to use the junction law. Finish off with that. You get X from here, Y from here. R equivalent will be V by I1 plus I5. Is this clear, everyone? So even after using axial symmetry, bisector symmetry, you still have to use Kirchhoff's junction law. That didn't happen in capacitors, if you remember. If you would have one or two symmetries, you would use to get the answers. Series parallel ho jata tha sab. Yeah, so if they ask you in advance, you can expect something of this sort. You have to do work. Mains mein this will not happen. You either get series parallel, your job's done, you'll get the answers. Is this clear, everyone? Any doubts? Any step like why did I do this? What is that? Anything that you're not clear? Next one. Next one. Next one is also a good one. Literally every question that I'm showing is like a proper advanced one. Some are lengthy, some you need to think. This is a question where it is easy to solve, but you need to think. All batteries are 1 volt. All resistors are 1 ohm. This point is B and this point is A. Find VA minus VB. How do we approach them? 8 batteries. Did you guys figure out the potentials? Did you name them? That you should have done. If I call this 0, this will be 1, 2, 3, 4. If I call this x, this is x plus 1, x plus 2, x plus 3, x plus 4. Did you figure out till here? Now there are like 1, 2, 3, 4, 5 nodes. I have to apply junction law 5 times. But I want to tell you something. See, listen. Imagine I have a big circuit, different batteries and everything. Tell me what you think about this statement. If I just draw a random line through the middle of the circuit. If I just draw a random line through the middle of the circuit. So what I'm saying is, whenever you have a battery, if a battery sends current I, the current I has to come back to the battery. Agreed? That means, can I say any current that crosses this line must have to cross back the line? Any current that crosses this line must have to go back through the line again, or else it won't reach the battery. Basically, this current will always form a loop, isn't it? Is that making sense? That means what I can say, if you take any circuit and if you draw any random line, the net current passing through this line must be 0. Everyone agrees with that statement? So instead of using junction law for everyone, I'll apply junction law for all of them at the same time. I will draw a line like this. Now, can I say all the current that is crossing this line must be 0? The total current crossing this line must be 0. Because think about it. Whatever current this battery sends will come back. Whatever current this battery sends will come back. This battery will come back. This battery will come back. The net current has to be 0. So junction law, right? You can apply for multiple junctions at the same time. I'll show you even a better way to figure this out. So that, but this idea is clear. That's a pretty good theoretical question actually. If a line is drawn through a circuit, the net current crossing through that any random line in a circuit is 0. And all this works because every battery, whatever it sends, it has to come back. So the total current crossing the line has to be 0. So some currents are going down, some currents are coming up. Net will be 0. That means this current I1, this current I2, I3, I4, I5, 6, 7, 8, 9. Nothing this way. Didn't I simply directly say the net current passing through this node, this node, this node, this node, and this node? The total current passing from the 5 nodes is 0. Hearing what we did? We are writing junction law for 5 nodes at the same time. So when you draw a line, that's what you did indirectly. You wrote all the current passing coming out of the nodes must be 0. Is that making sense? And whatever is between them is internal, isn't it? So I1 plus I2 plus I3 plus I4 plus I5, 7, 8, 9 is 0. Look at the first current, x plus 4 minus 4. You will see a symmetry here. This will be x by 1. X plus 3 minus 4. You'll find x minus 1. All rest are 1. So this will be x by 1, x minus 1 by 1, x by 1, x minus 1 by 1, x by 1, x minus 1 by 1, and x by 1. You solve this, you'll get 9x minus 4 is equal to 0. You'll get x is equal to 4 by 9. You want A and B, so this point was A and this point was B. So VB minus VA is X plus 2, which is 22 by 9. Easy to solve. Once you know what to do, it is easy to solve. This is what I'm saying. This is a question which is tough to think but easy to solve. So we are using junction law at a circuit level. It's like a line law now. Something like that. You have to call it a new name, but yeah, it works. And the simple idea is that every current that goes out of the battery has to come back. So if you draw any random line, meaning this circuit now, if I had drawn a line like this, current crossing that line has to be 0. Doesn't matter which line you take. Any doubts on this? Clear with this? I hope you can see a lot of different variety today. Told you, capacitors is still nothing. Resistors, you can do really deadly stuff. Clear? Next thing, Kirchhoff's voltage law. So what we saw was junction law. Kirchhoff's voltage law is useful. It has its own advantages, especially when you want to find potential between 2 points. But if you want to solve circuits, junction law is the best. Kirchhoff's voltage law or loop law. So there are names for this. So we'll let a variation of this. So the potential difference between 2 points is sum of the potential difference. So if you want to go from A to B, choose a path and add all the potential difference of all the elements between them. That must be the potential difference between the 2 points. The potential difference across the elements. In any path between the 2 points. In a closed loop, the potential difference is 0. If you come back to the same point, the sum of the potential differences will be 0. Sign convention, we have done this before for capacitors. Remember, we follow a very simple sign convention. If you go from higher to lower, it decreases. Lower to higher, it increases. Simple. So if you have a battery, if you have a resistor, if you have a capacitor, negative terminal, positive terminal. If you go from negative to positive terminal, potential will rise, plus V. If you go from positive to negative, minus V. Look at this thing. For a resistor, current always goes from higher to lower potential. Agreed? So if you go in the direction of the current, potential will increase, decrease. If you go opposite to the current, the potential will increase. Remember, battery ka potential has nothing to do with current. For example, see, if you have a battery like this, and if current is going into the battery, and if you go from minus to plus, it is still plus V. Are you getting it? Battery doesn't care about the current. You're getting it? Potential difference across a battery is V. Whether the current is there, current is not there, current is going in, it doesn't matter. If this is the positive plate plus Q and minus plate, if you go from positive to negative plate, potential drops minus Q by C. If you go from negative to positive plate, potential rises Q by C. Clear with the convention? And remember how we write the steps? Kirchhoff's loop law. Step 1, if there is more than one battery, assume current I from any one battery. Using junction law, distribute the currents. Apply Kirchhoff's law such that all elements are covered and solve. So instead of charge, we will use now currents. The steps are the exactly same. So let me give you one sample circuit so that we are sure your sign convention is good. R1, R2, R3, R4, R5, R6, R7, R8. Now for convenience, I will choose the current. So let this be I. So let this be I1. This will be I minus I1. Let this be I2. Then this guy will be I minus I1 minus I2. Let this be I3. Then the balance here will be I minus I1 minus I2 minus I3. This will be I1 plus I2, and this will be I1 plus I2 plus I3. And finally, I comes out. Is the distribution clear? So write me an equation for this loop, for the center loop, for this loop, and I want through the battery and this loop. 4 equations. Get them. Let's see whether you're getting the signs right. And also get me this. Suppose if I want to go from this point here, A, to this point here, B, also write VA minus VB. You can go from A to B any way you want. You can go like this, you can go like this, both will give the same answer. So get me the 4 equations, the 4 loops, and find VA minus VB. I just want to see whether you're getting the signs right. Let's see. The left loop. You can start from anywhere. I'll start from here. Only the terms will get jumbled up. Minus I1 R1, because I'm going in the direction of the current, the potential will decrease. Then I'm going through R7. I'm going opposite to it. So plus I2 R7. Then again, I'm going opposite to I minus I1 R4. Check whether you got the same signs. The middle loop, I'll start from here. I1 plus I2 R2. I3 R8. R5, there's one more term here. I2 is also there. In this thing, there are 4 resistors. The right loop is minus I1 plus I2 plus I3 R3. Then you're going minus I3 R8 is 0. If you go through the big loop, it will be V I1 R1 minus I1 plus I2 R2 I1 plus I2 plus I3 R3. Yep, and back. What about VA minus VB? Now, see, this is something else. Huh? Think of like this. Let's say you're at a height of 10 meters. From here, if you climb 1 meter, what is your new height? Plus 1, 11, isn't it? Let's say you climb 2 meters. What is your new height? Plus 2. Then you climbed 1 meter down. Then minus 1. 3 meters up. Plus 3. So this will be a new height, isn't it? You can just keep adding. So this, Kirchhoff loop law, right? You can actually use partially also from one point to another point. Now see, if I start at point A and I'll try to go like this. So I'm going through R7 in the direction of current. So what will happen? It should drop. So VA minus I2 R7. Then I went through this guy, which will be minus I1 plus I2 R2, and I reached VB. Is it making sense how I'm writing? You need not complete a loop. You can start at some point and stop at some point. Is that making sense? So VA, you had some potential. When you went through this, it decreased by minus I2 R7. When you went through this, you decreased by minus I1 plus I2 R2. Then what is left must be VB. Is that logic making sense? You could have done the same thing this way also. Answer would still be same. Please check the equations. Anyone, any sign convention, anything you're not clear, please ask. Let's see a question. Six volt, 1 ohm, 2 ohm, 3 ohm, 2 ohm, 4 volt, 10 volt, 2 ohm, 1 ohm, and 2 ohm. This is A and this is B. Find VA minus VB. Now look at this question. Let me ask you this. What is the current in this branch? Let's start from there. What is the current in that branch? So let me ask you another way. Let's say current I comes from this battery. This is I, and let's say some current goes through here. Then this current will be I minus I, and you get I minus I. Did you notice something? The battery sent current I, but I got back only I minus I. Did you see the problem there? The problem here is the current which went in this, there is no way for it to come back, isn't it? There is no exit. There is only an entry, but there is no exit. There will be no current in this branch. If there had been a wire here, then the current would have come back. So if you connect two circuits with a single wire or a single branch, that branch will never have a current, because any current that goes through this has no way to come back. Then the only possibility is there is no current in that branch. Is that making sense? So that is how you start the question. So without that, you won't be able to start. So if this is I, this is I minus I, and this is small I, and this is I minus I. So current leaving this 6-volt battery and returning back must be same. Therefore, I must be equal to I minus I. Therefore, I is equal to 0. Getting it? So there will be no current in the connecting branch. The logical way of figuring out is there is no way for the current to come back. Is that clear, everyone? So both the circuits will behave independent of each other. Now can you solve? So let this current be I1. This is I1, I1, I1. This current is I2, 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 I2. This middle current is 0, 0. So you can see here 1, 3, 2. All three are in series, isn't it? So I1 will be 1 ampere, 6 by 6. I2 will be 2, 2, 1 in series, 5 ohms. So that is 10 by 5, 2 amperes. The two circuits become independent of each other. Is it 0 since both are next to the negative point? What do you mean by negative point?
The negative terminal of the battery.
So negative terminal of a battery, what is the problem with the negative terminal of a battery? So you mean to say if you keep something like this, And if you put a resistor like this, there'll be no current because it's connected to negative terminal. What does a negative terminal do? Tell me. What does a battery do? Creates potential difference. That's it. Don't assume stuff, huh? This is all imagination. Negative terminal kya karta hai? Always ask yourself that question. Nothing. The resistor doesn't care who is a negative terminal, who is a potential, and who is a positive terminal. Now you need to go from A to B. So yeah, I can go anywhere I want. I'll go like this. You can choose any other path you want. You'll get the same answer. So I'll go like this, this, and this. So there, I'm starting at A. I'm going through the battery, +6. Then I'm going through I1 into 2. Then I'm going through small I into 2, which is 0. Then I'm going through a battery 4. Then I'm going opposite to I2, so that is plus I2 into 2. Then I'm going opposite to the battery -10. Then I reached VB. Please check this equation. So you can start at a point and you can reach any point. You need not complete a loop. You can stop in the middle. So you're starting at VA, the battery 6 volt increased you +6, the 2 ohm decreased you minus I12, 4 volt increase, and yeah, so on. So this is VA +6, this is -2, this is 0, this is 4, and this is 4, and this is -10. How much is this? 1, 6, and 4 will cancel. That is 2. So VA minus VB is -2 volt. Yes. Got it. It's a pretty good one. This was a PYQ. They did ask a question like this in mains once, long back. And the main catch in the question was this circuit has no current. Any doubts on this? Vihan, clear with that? That negative terminal has nothing to do with that. Matlab, if you even think about it, whatever I got here, this was 6, isn't it? So this thing still has a potential.
So if like we had just one circuit completely independent, means not connected to anything, so then at the starting we would assume 6 volt, right? At the
You will assume 0 somewhere, then you'll assume 6. You'll assume. Start with a 0 first of all. Then, so you mean to say if you put a resistor across a 0, can't I have a -1 here to get current?
Yes, sir.
And then what is the problem?
But so its actual potential is what?
Who cares? In the V is equal to IR, what is V? Actual potential.
So,
There is nothing called actual potential in the entire universe. Tell me, how do we define potential? Do we define potential in the first place? Anyone remembers how we define potential? Anyone remembers? Gravitational potential, how did we define it? By choosing a reference at infinity. You always choose a reference. There is nothing called absolute potential. Someone has to be 0. Getting it? So you always define potential difference. Potential is a useless quantity. Next one. This you remember. It's like saying the same thing, in the world, like what is at rest in the universe? Nothing is at rest. It's absolute. There's no absolute rest. Remember this? We did this example before. Now we will solve this. There we have two currents here. This guy is I1. This current here is I2. The question is find I1 minus I2. All resistors are 4 ohms and all batteries are 10 volts. Get the maze. We have done this in capacitors. All resistors are 4 ohms and all voltages are 10 volts. Do you guys find it? No, Aditya, that is wrong. Try. I'll give you a minute. I thought you guys will get it by now. Find a path where there's only one resistor and everything else is a battery. I hope you found the path. So for this guy, for this, and look at this thing. This battery is plus V. This battery is plus V. This battery is plus V. This is minus V. This is plus V. This is minus V. So there are 4 batteries in the same direction and 2 batteries in the opposite direction. So if you write a Kirchhoff's law, minus I1 R plus V plus V plus V minus plus minus is 0. You get 2V is equal to minus I1, 2V is equal to I1R. Battery is 20, this is 4I1. So I1 is 5 ampere. What left side? What left side are you talking about?
The bottommost point से आप left side जाएंगे तो going.
जाओ, same आएगा. This and this will cancel. Still the same answer. Check करके देखो. Plus V, plus V, plus V, minus V. You got 2V. Doesn't matter how you go. The answer can't change just because you change the path.
5 होगी तो आंसर 5 होगी 5 एम्पियर ही है.
क्वेश्चन वो नहीं है आंसर. क्या पूछा तू? पढ़ नहीं रहे आप. क्वेश्चन इज I1 minus E2.
अच्छा
Drunkard. Now see this thing. These 4 are in series here. So that will be how much? 5R by 2. So I'll go like this. I will follow this guy. Then I'll come back like this. So this will be minus I2 5R by 2. I'm going through a battery. I'm going through a battery and I'm done. So 2V is equal to 5 I2R by 2. This is 20 and that is 4 and 10 I2. I2 is 2 ampere. You want the difference between them? It's 3 ampere. Got it? 3 amperes. Any doubts on this? You always have to check, are you going from positive to negative or negative to positive? You can take any path, but make sure you don't touch a second resistor. As long as you don't touch the second resistor, you can go in any path. Answer will come same. Clear? Now, Kirchhoff's this loop law, right, will be especially useful, when you start dealing with different elements. Like if someone puts a capacitor, resistor, battery, and later on we'll also have something called an inductor. You can dump everything. So let me show you a question how it looks. Let's say we have a capacitor, we have a resistor, and we have a battery. 6-volt battery, 2 ohm. Let's say this is 2 microfarad. Let's say this charge is 6 microcoulomb. This is minus 6 microcoulomb. Let's say this is 3 ampere. This is point A and this is point B. Find VB minus VA. Three. Be careful with the sign convention that I taught you. This is not the actual question. Three minus three minus three. Okay, let's see. Most of you are getting it. I'll start from A, VA. I'm going through the battery. I'm going in the battery from negative to positive, so plus 6. I'm going through the resistor in the direction of the current, so potential should drop, minus 3 into 2. Then I'm going from a positive to negative plate in a capacitor, so potential drops again, minus 6 microcoulomb by 2 microfarad. Then I reached B. You getting how I did this? So each terminal you just see, are you going decreasing or increasing? VA plus 6 minus 6 minus 3 is VB. You want VB minus VA, minus 3 volts. Easy? Let's see the question. This is grounded. Let's say this is 2 farad. This is 1 farad. 2 ohm, 1 ohm, 3 volt, 5 volt. This is also 1 ohm. Let's make it 3 ohms. This is the positive plate where charge Q is equal to T square. This is the positive plate where this charge Q2 is equal to 2T. This is point A, this is point B, this is point C, and this is point D. Find the potential at ABCD when T is equal to 2 seconds. Technically speaking, here later on I'll put an inductor here, so that would have made it a pretty good question. These are the kind of questions where the Kirchhoff's loop law will be very good. Yeah, you can use junction law also, but wait, I forgot to give one more point. Through this branch, 2 ampere current is flowing. You need that. The current in the A to D branch is 2 ampere. So the main thing in this thing, right? First of all, we need to figure out what is the current in this branch. If you take it as I1 and if you take it as I2, I1 is dq2 by dt, which is 2t. I2 is dq1 by dt, which is 2. At t is equal to 2 seconds, I1 is 4 ampere and I2 is 2 ampere. There, now I got the current in the branches. Then this current will be how much? That is 4 and 2. So this current is 4 ampere, isn't it? And this is grounded, so this is 0. There, now you can start. So this I2 was 2 ampere and I1 is 4 ampere, and I know the current in all the branches. Now I can apply the junction law from 0 to A, then A to C, A to B, and A to D. Look at this. I'll go from O to A. I'll start from O is 0 here. So I'll start from A, which is VA. I'm going opposite to the 3 ohms. So that will be plus 4 into 3. Then there's a minus 5 volt battery and I reach 0. So VA will be 12 minus 5. How much is that? Minus 8 volts. Is that clear? I'm going from A to O. I'm going in this direction. Since I'm going opposite to the current, it is 4 into 3. I'll add up. And the battery is opposite to minus 5. Sure? That is 12 minus 5. 7, na? Okay. Then let's go from A to B. So VA, I'll go to A to B. That is minus I1 4 into 2. I'm going through a capacitor. Minus Q2 by 2 farad is equal to VB. What is Q2? Q1 is 4 coulombs and Q2 is also 4 coulombs. This is minus 8 and this is 2 is equal to VB. This is minus 7 and that is minus 17 volts. Got it? Yeah. That's it. You just do for each branch like that and you're done. You'll go from VA plus 1 into 2. You're going through the battery plus 3. You reached VD. This is minus 7 and this is plus 5 is equal to VD. So VD is equal to minus 2. Similarly, go from A to C. So VA, there is current is useless. You're going from negative to positive plate. So plus, this is Q1. Q2 by 1 is equal to VC. Got this? 4 VA7 minus 3. This is how you do this for each branch. Any doubts on this? This is how we can use this Kirchhoff's law thing. So that is a bit about resistors, capacitors, and stuff. So next class, when we catch up here, we'll continue from more. We will see what happens if you connect a resistor and a capacitor, and if you keep a combination of them. RC circuits, quite an important thing, has a pretty good weightage. We will work on that. Okay, with that, we'll wrap up for the day, right? And we'll continue again from here on Monday. So any doubts, anything you can stay back and ask, or else you're free to leave. So take care, stay safe. I'll see you on Monday.